Good morning, everyone. This is our second day of this workshop. Yesterday, Vinod sir gave us introduction about LoRaWAN. Today's session will be on a little advanced topic, and today's session will be delivered by Mr. Vikas Chaudhary. He is the senior manager at SSTPL, and he has 9 years of experience. So without wasting much time, I'll request the honorable speaker to start our today's session. Over to you, Vikas sir.
Okay, thanks, Docs Pro team. So welcome to all. Myself Vikas Chaudhary. I am a senior manager in SSTPL. Today we are presenting the hardware architecture of our modules and LoRa architectures. So yesterday we discussed on the IoT and some LoRa network. We developed so many modules for the LoRa communications, and today we are discussing on these are the modules and how they are communicating and how we can implement these modules. Like what are the key component of these module also. Let's start with the mini mode 2.0. It has the Semtech SX1272 transceiver, one thing, and another thing is microcontroller. Microcontroller is STM32 ARM processor. So let's discuss with the key features of this device. It has the 20 dBm of output power, and it supports INR 865 ISM band and EU 868 and AS 293 bands also. So let's discuss on what is the key component of this. I already told you SX1272 and STM32 is the key component of this device. So it has the similar some features also. Let's discuss about the SX1272. SX1272 is a LoRa based RF engine, and it supports 157 dBm of maximum link budget. Link budget means maximum power transmitted by the transceiver and plus the minimum receiving sensitivity, that is called link budget, and 20 dBm output power and 40 dBm also. It supports the two output power like 14 dBm and 20 dBm. It is programmable by the software. Programmable bits are up to 300 kbps and high speed, high sensitivity up to minus 137 dBm. And the low power consumption in terms of RX current is 10 milliampere, and it supports the frequency shifting GFSK, MSK, MSK and LoRa also. Preamble detections and automatic RF sense and CAT detection also. So let's discuss about the internal diagram of this IC or internal block diagram of this IC. If we go through these peripherals, it has the MOSI, MISO and SCK pins, that is the SPI interface, and some of the DIOs. DIO means some digital input-output connections for the interrupt purpose. On the SPI, this IC receives some registers configuration by which we can configure this IC and send data to the network. How it's happened? So there is inbuilt LoRa modulator and FSK modulator and high pass filter. After that, the PLL is here. PLL, what it did? It matches the phase of the input signal to the output signals, because phase should be the same as per the input signal. Here we can see there are two outputs, that is a RFO and RF boost. As mentioned earlier, there are two output powers. First of all, 20 dBm and second one is the 14 dBm. So we have the two output pins. That's why we configure that if we want a 14 dBm and 20 dBm. If we are talking about the European region, the more than 14 dBm is not allowed. That's why they introduced a different pin for that. Semtech introduced a different pin that gives the maximum output 14 dBm. Similar way, on the receiving side, this is the receiving part of the IC. First of all, they introduce a balance circuit for the balancing and non-balancing input signal, and this input signal is converted to the digital input. Here we can see the analog is coming from the RF signals, and this will convert to the digital signal. Here we got the low pass filter and LoRa demodulator, and this demodulated signal is stored in the LoRa FIFO. It is a stack buffer where we can read the data and get the data by the SPI interface. First of all, when the data is received from the LoRa buffer, it gives the interrupt, and this interrupt is mentioned, denoted by the DIO interrupts. So once we got the interrupt, we can read the data. This is the basic functionality of the LoRa communications. Like once we go to the on device side, we have the Cortex M0 processor STM32 on this module, and this is a very ultra low power. It takes the current consumption of less than 1 microampere. The maximum speed is 32 megahertz, and ADC and UART, I2C and SPI peripherals are inbuilt. It has the timers and counters also, internal RTC, flash is 128 KB of flash and 16 KB of RAM, and 6 KB of internal EEPROM to store the MAC address of our device. And this is the LQF package, 48 pins. So this is the microcontroller we introduced with this module. So similarly, we have the different modules, that is LLCC68 and SX1272 and SX1262 also. Here, these have the different parameters on which we can distinguish these. SX1272 has a 20 dBm output power. Apart from this, SX1262 have the 22 dBm output power. LLCC68 also having the same output power, the 22 dBm. But the SF spreading factor is not more than the 9. Let's say it's LLCC68 supports 5 to SF9 only, not 11, 10, 11 and 12. Only support 5 to 9. So these are the key parameters of the micro mode 22. This is also introduced by the Semtech. 22 dBm output power, same RF band supports, and UFL. You can connect the UFL and helical antenna as well. And if you want to connect some of the peripherals like I2C, UART or ADC on this, you can also connect with this. If we are talking about the current consumption while we are transfer a data or receiving a data and we are in idle mode, we can calculate over here. It takes the less than 10 microampere if your device is sleep. And whenever the device is receiving mode, it takes the approx 23 milliampere. In transmission mode, it takes the 123 milliampere of current. Yesterday we discussed about the SF and the distance we cover on the field. Here the main factor is SF and the distance is covered. Let's suppose our device is transmitting on the SF12. It's covered the maximum distance. Yesterday we discussed the coverage in urban area and rural area. In rural area, it's covered up to the 15 kilometers. If on 15 kilometers, it is possible on SF due to SF12. Once your devices get nearby to the gateway, it should communicate with the SF7 because of the time on air should be less as possible because of the to reduce the consumption of the network. So due to the SF, it also affect on the receiving sensitivity. If we are sending on the SF12, the max sensitivity get the maximize like 127 dBm. If we same packet we are sending on SF, then maximum receiving sensitivity will be minus 120 dBm. That means once we get down to the SF, the sensitivity will be less. Mean our coverage area will be less. Coverage area will be less. Similar way, the SNR also affects. If we see here, the spreading factor 12 is capable of receiving the minus 20 dBm of SNR. Instead of if we are getting the SNR 6, it receives the minus 5 dBm of SNR. That means SF12 is more robust as compared to the 6 or 7. Now discuss about the products. We discussed earlier. We discussed about this module only. Now we discuss about the product. What we want to develop. Like here is a sample of temperature humidity sensor. It has a sensor which monitor the temperature and the humidity, and a LoRa module. For the supply of this device, we have the battery also. Now, how this sensor is connected with this IC or connected with this module. So this sensor supports I2C protocol. So that's why this sensor can be connected with this module. And the battery life of this module is more than 1 year we are giving. Similarly, we can connect this module with the water meter utilities also. Water meter supports the UART communication, RS485 communication, and RS232 communications. For this, it has a longer battery lifetime, and the power supply of this module is separated. This is the ultrasonic meter. Similarly, we can connect the pulse meter also, as mentioned earlier. This is the second, one more use case of module. We can connect with the energy meters. Energy meter also support the UART 485 and RS485 and RS232 and send data to the server. Before that, we need some command from this meter manufacturer, and they share with the some commands for this, and we get the data from the meter and send to the server. Now, let's discuss about the LoRaWAN architecture. This is also discussed with earlier. Here are the some sensors and devices, and here is the gateways, and all these data coming from the sensors is going to the server. And server have the some applications also. So, and the data will be reverse also, maybe up. Once the data is coming from the device to gateway, that is the uplink, and the data is going down from like gateway to device, that is the downlink. So once the server is installed, let's discuss about the gateway now. Okay, here is the outdoor gateway. Here is the outdoor gateway, and it has the SX13 transceiver. It has output power of 30 dB, European band and Indian band as well. Receiving sensitivity is 145 dBm, and it supports 4G LTE, Ethernet and Wi-Fi backhauling, and it can be mounted on pole, and it also supports a 40 volt power supply on PoE. Here is the internal architecture of this outdoor gateway. Here we have a Raspberry Pi system which has Cortex A53, 16 GB of internal RAM, flash, 1 GB of RAM. Apart from this, it has the SX1301, and this SX1301 is connected to the analog front end, that is SX1257, and this is terminated with 50 ohm antenna, 50 ohm impedance antenna matching. Now discuss about the SX1301. SX1301 is a baseband processor. It supports up to 8 LoRa channel. That means it can receive at a time 8 channels. If we can see here, they are receiving signals from the analog front end and receiving the 8 channels over here at a time. It also works in a similar way. It also works in a similar way as SX1272 supports. Like SX1272 have a single channel, but it has the 8 channel for transmitting and receiving. So here is also a LoRa demodulator, and this signals is sent to the LoRa front end. On receiving side, similar happening. The LoRa analog front end send data to this LoRa demodulator. Now, let's discuss about the key features of SX1301. The receiving sensitivity of gateway is minus 142.5 dBm sensitivity. Able to operate with negative SNR means if we are talking about the signal to noise ratio, it's operate in very noisy environment. Because of in a rural area, the noise level is minus 90 or 100 dBm in normal conditions. But it's also work with the minus 142 dBm. That means it's work on the negative SNR also. Emulate 49 LoRa demodulator, as we discussed yesterday also. It supports 48 channels at a time if they are on say different frequencies and different SF, means spreading factors. It has 10 programmable demodulable paths and dynamic adaptive data rate adoption. That means it can receive the data from the different SF. Here is the analog front end. SX1257 block diagram is there. So here is also support the SPI communications. It takes the data from the SX1301, the baseband processor, and the synthesizer generate the frequency for the baseband carrier frequency, and this carrier frequency is mixed with the original signal and transmitted to the by the antenna itself. Similar way, on the receiving side, we have the LNA also, pre-fired filters also, and get this signal to the SX1302, 01 or 02. Okay. It's a IQ signal is a modulated and demodulated signal which are connected with the SX1301 and 1257, SX1257. It's a half duplex manner. That means we can transmit, when we are transmitting the data, we cannot receive the data. It has the inbuilt LNA also, low noise amplifier, to boost up the signal. When we are getting the signal, it's very weak. Analog TX and RX pre-filtering, programmable tap, FIR filters, linear TX amplifier for both transmitter and receiver. After that, let's discuss about this one. As per the architecture, we discuss about the devices, gateway. Now we are discussing about the server also. What is the key role of the server? Server maintain and control the end devices, send and store the data to the application servers through APIs, store the device data into in the database for the long time, register and deregister of the devices, maintain user applications also, check and monitor the gateway status, decrypt and encrypt the end devices also. Because this is the AES 128 encryption, so we need to decrypt that data also for the security purpose. Now, discuss about the LoRa frame. Because LoRa server work on the pre-priority frame architecture, so there should be a frame in which once the user sending the in a similar manner, then data will be accepted. Otherwise, data will be ignored by the server. So what is that? First of all, there should be a preamble, uh, frame data, PSDR, frame CRC, and payload. This is the actual payload sent by the device, and this one is auto-generated by the devices. And here is the CRC. Further, this payload is divided in several sections. This is the MSDR, MAC header, MAC payload, and MIC. Further, this MAC payload is divided into FSDR and frame payload, or F port. That means this is the port on which you are sending data, and this is the actual data you are sending. Further, this MAC payload is divided into, this is the address. Every device have a unique address. So this is the address by which the server identify the data it is registered on server or not. It is the 4-byte section. Here is the F control, F count. F count is also possible, also introduced because the how many frame counts we are introducing on uplink. That means how many uplink we are receiving and how many downlink are we receiving from the server. Some of the command are also introduced and they are mentioned in F option part only. So here we have the two joining procedure on server side, or once with the device is sending, first of all they had to join a server. There are two methods. One is activation by personalization and another one is over the air activation. For the proper communication with the server, three things are needed: device address, network session key, and application session key. In case of ABP, three parameters: device address, network session key, and application session key are pre-installed on device side and on server side also. But in OTA case, first of all, we have to send the joining request to the server, and after that server send back these parameters to device to store and start communication and start sending the data. OTA is more secure as compared to ABP. We developed so many products in SSTPL. Here is the one of our product, that is a parking sensor. It's work on the magnetic detection. Once some car or some vehicles is coming over the near, the magnetic field of the sensor is changed. On the basis of changing in magnetic field, we calculate the someone is coming and someone is parked over here. It has a similar feature as mini mode or our module have. like sensitivity minus 137 dBm and operating temperature minus 40 to 85 degree. LoRaWAN protocol it supports, inbuilt EEPROM it has, and battery life more than 2 years. So this is the gas meter AMR. This is the inductive meter. One magnetic needle is rotating inside the meter, and this rotation is detected by our module on the induction basis, like LC sensors. So it has a similar features like 20 dBm of output power. It supports 868 to and Indian 865 ISM band. Receiving sensitivity is similar, 137 dBm, and range up to 5 kilometer. This is the water meter, pulse-based water meter, or maybe a inductive-based water meter. As mentioned in the gas meter, also the same phenomena is also in gas water meter also. In the magnetic meter, the one rotating magnet is there inside the meter, and we can capture the movement of that by the reed switch. So we connect with the that reed switch to our module. We can similarly develop the further products on this. Here we have the NEMA connector, that is the street light, and street light functionality is controlled by this NEMA connector, 7-pin NEMA connector. It has the inbuilt LoRa module, and it can also dimming the street light on off the street light as per the environmental sensor also. This is another example of a street light controller. This is the NEMA base, is the retrofit, and this is the street light controller. You can connect with any of the street light to control the street light, make the on and off. It has the similar features as mentioned in the LoRa module. Apart from this can also the dimming the street lights and on of the street light. Apart from these products, we have developed the energy meters for that, as mentioned earlier also, water meters, gas meters, street lights, parking sensors, and waste management also. Waste management, we developed the ultrasonic smart dustbin and environmental sensor. We developed the gas meters, gas monitoring, environmental sensor. For healthcare, we developed the temperature sensor, and agriculture for the soil and moisture sensors.
So with this, there are many use cases around LoRaWAN. LoRaWAN has been gaining traction across the globe in various use cases, starting from agriculture, energy, water gas, whatever mentioned here. What do you want to understand from all of you from the previous slides where we have been discussing with LoRaWAN technology, the architecture of LoRaWAN, or maybe the baseband receiver. So this is the baseband receiver discussed earlier. We see how the packet is handled. We see how RF has been synchronized as a single IC solution. So this makes LoRaWAN altogether a different ball game in comparison to Wi-Fi or comparison to you say this 4G, 2G, 3G. In LoRaWAN, you can create your own network, your private network. You can design your own sensors. You can align with them end nodes as per your requirement, our module support to develop your products with our module. You can integrate gateways with your servers. Even we can have a LoRaWAN network server running in a gateway. So different kind of gateway architecture is also available, which supports different kind of backhauls in different pricing range as well. So here what we see that is a 61301 gateway having the SX125C1 as a front end ICs. We also have gateways with SX1302, which is a newer version of chipset. It is mainly to be used for automation systems in building automation. It has more frequency support in terms of SF. We also have SX1303 coming up with more stable, timing stamp solution. So when you want to use geolocation services, it helps in that way. Bringing those architecture, on the floor, you can design a different kind of application. Like in place of 1257, there is another chipset which is 1250, which has inbuilt power capacity of 22 dBm. So when we say architecture, we for SX1257, you need to add a power amplifier. In 1250, you do not need to add power amplifier. So this is day by day, we see that gateway architecture has been, getting enhanced. We see that geolocation services has been done with the LR1110, the new chipset on LoRaWAN, which has the embedded solution of geolocation service with GPS, Wi-Fi scanning, and LoRaWAN. So with the triangulation method of all these services, scanning the passive scanning of Wi-Fi signals, we can create a geolocation services on that as well. So we discussed a lot about this yesterday. This architecture, if anybody has question, they can ask. We will run Q&A parallelly in this. Please write question on chat box. We will go the slide by slide if you have questions. Okay, so we'll move to next slide. So this is the architecture. If somebody has question, they can ask me. Anyone has the question about clarity of how this chipset behaves in terms of communication? You want to ask something about CAD detection or the RF sensing technology or CRC handling or something kind of that, they can ask question. Yeah. So advantage of STM32 is that STM32 helps you to build code very easily. ST has created an ecosystem which everyone can write a code. So when we compare with microchip or other chipset manufacturers, they are also have a good ecosystem. But ST predominantly started developing LoRaWAN ecosystem for everyone to use. Like if you even don't want to use our LoRaWAN stack, you can write your own LoRaWAN stack with the help of ST ecosystem. ST provides stack to you for LoRaWAN. You can write your own applications in this module. Even you can use their ST ready code for ping communication, like device-to-device communications. LoRaWAN different specifications are there. There is 1.01, then 1.02. So these specifications are, in terms of MAC commands, they have difference. So like your LoRaWAN server uses all classes of standard in LoRaWAN standard, but you can't develop all them on the device side. So ST provides the flexibility to use any of these specifications. Go to the website or ST, you type LoRa, they will have resources available for LoRa. You can develop those products. So STM32, you can use for your projects like we can provide you a basic LoRaWAN stack with our module, and we will provide you the firmware for that. The source code can also be provided from our side. You can write your project in terms of like you want to attach a sensor to it, you want to have some analog input to coming in, and you want to use that. All those can be used with this STM32 microcontroller. So this is how we can use it. So questions are coming on STM32 rather than SX1272. We think that this is a LoRaWAN webinar, so we were expecting questions on SX1272 chipset, how the LoRaWAN works. So I'll reiterate that this CAD detection is a technology where you can sense the incoming RF signal, which helps in RF interference. So there you can decide when you want to send the data, the uplink, when to send the uplink. So still 32 we discussed. The block diagram we already discussed in detail. If somebody want to ask something about this, we can go through this. So here is important thing is that the PLL generation is very very efficient. So when you have 125 kilohertz of channel bandwidth, it is very hard to keep the envelope in decided parameters, the frequency envelope. But with the very high optimized PLL generation helps in SX1272 to reach precise frequency parameters, and that is the reason we can reach maximum distances. We have tested up to 34 kilometers with SX1272, building a module with the STM32. The same module we discussed in the beginning, Minimo 20. We have achieved 34 kilometer of range. So you can see the power of LoRaWAN with the ranges we have covered. And we are talking about two-way communication where both-way communication was happening. And we tested it in the Jaipur city only. Our gateway was installed one of the top location, highest. You can't say highest, but it's a quite high location in one of the high building. And the other person was driving on the highway, which is towards the south of this Jaipur. So DIO 5.
Yeah, it's a DIO 0 to 5. There are 6 extra interrupts from the SX1272 to the to the STM32. That denote the different interrupts once we got the data from the SX1272, and once we send the data, that got the interrupt, and once the CAD is detection over there, that the we got the interrupt, and once the failure of the data, once we got the interrupt also. Similarly, there are the 5 or 6 interrupts is there.
Yes, so mainly for the communication with STM32, like sending a data, receiving a TX done, RX done, or detection of some frequencies, some channel activities happening. So, and then many others. So there are 6 DIUs are there. So say this is how secure the ecosystem is. In terms of data security, it is end-to-end encrypted with the ES128-bit encryption. So you can best assure about the security of data. Top of this, you can also add a secure element with the module where you can fix your module ID, your keys, parameters, all that can be secured in secure element. You can add that. This is another security on top of the AS128 bit. Next is talking about a network congestion. So LoRa is meant for that only. We listen first. It's called as listen before talk. Albeit is already implemented in gateways. So whenever a signal has been transmitted in the air, gateway first listen, then only send. So if some congestion is happening, so that congestion can be taken care by gateway. Also on the device, we have the CAT detection. So device will send data only when there is a no network congestion. So we discussed this earlier about the LoRa and modulation and FSK modulation. LoRa works in CSS spectrum. Chips are created, up chips and down chips, and then it has been modulated over a time. So SF7 to SF12 are spreading factors, which is not available in FSK. FSK is quite different. You create frequencies keys, and that is on frequency domain, where we are talking about time domain. Also on the time domain, we have the chips. Yes. So the count of chips in SF6 maybe 60 is kind of, and the count of chips in SF12 for the same packet will be somewhere 5,000. So this is the basic difference, the modulation. So we discussed already about this STM32. So it's ultra low power. We discussed everything. We discussed. We have the EEPROM available in this. So like somebody want to use it for storage of some data, maybe like you do it in a water meter or some very low data requirement. You can use this EEPROM. And further, you can use for other memory can be attached over a Y2C or a SPI with this. But this is available only in our mini mode module, not other modules it is available. So this is already discussed. If any has some question, you can ask. The different indications, a different type of STM32 with different pinouts, a different requirement. Like this is 2.5 is another module which is having larger output power. So if you want to send data in longer ranges, you can use this module. But it is predominantly for sending the data from long distances, not suggested for two-way communication because gateway will not able to support in that long ranges. Any new technology competition for LoRa? There are technologies coming up to copy LoRa. They are trying to copy LoRa. So, but their ecosystem is not developed. So there's no need to shift to new technologies. They just copy the LoRa. What the LoRa is done, they're trying to do that same with some other kind of chips. So they will not have SF7, SF6. They will have some other kind of spreading factors. But there's no mean to use other technology when the ecosystem is available for LoRa. In LoRa, you say 600, more than 600 companies are already part of the LoRa alliance, and every day, new companies coming up to support LoRa ecosystem. Like we started in 2016 as a commercial development, and we come up with a 2018 as the first LoRaWAN module with us. This gives us, about ecosystem, how large, how old ecosystem is. So other technology is not there in the competition. Even NB-IoT is not at that level as of now. We don't have infrastructure ready for NB-IoT across India, even across globe. LTE-M is another technology which has been used for IoT with a higher throughput, but still, it is only in some part of North America and some part of Europe it is not available. But the LoRa is a technology is available across the globe. You can see anywhere you want to support LoRa, you have network partner available, like they have dedicated network available for LoRaWAN. You'll have module partners available. You also have products ready with LoRa. Some meter company may have LoRa inbuilt with their energy meter, water meter, gas meter. You can buy them. You can have the sensors available from, but you will not find it on NB-IoT or LTM or some Sigfox. So there is how LoRa is positioned against other technologies. So this is already discussed. Somebody want to have question on this power consumption or transmit power or receive power? They can ask. No question. Any question on this slide? But still, this is a very important slide. This all tells about LoRa. It tells about why LoRa is so powerful in terms of IoT communication. This chips, it is creating huge difference among all IoT technologies. The data rate is not big, but you can achieve big, large ranges. Thousands of sensors are connected within gateway, still having communication happening. We discussed it yesterday also. Today also we discuss in detail. So no need. Anything question on this? How the integration has happened, or if you want to do this integration with our module, how you can do this. So this battery is primary battery which is having a long battery life. If you taking data the lesser frequencies like 2-3 times a day, you can achieve even bigger life size, like 5 years kind of. So the water meter, we have just shown here as an example. Yes, some question is there. How do you measure battery life? So LoRa, if you go to the LoRa website, the Semtech website, they also provide a battery consumption, battery calculator. On top of that, we measure battery life through our tools. We have tools to measure battery consumptions. We use the battery life according to that. Typically, LoRa consumes very less power when it is in sleep. When it transmits on a highest power, it will go up to 120 milliampere. So you can calculate by the way that how many times in a day it will transmit, how many times in a day it will be in sleep. So seconds has to be calculated. Then we have to go to the WH of a battery and then calculate back how the battery life will be. Here we also need to consider the leakage current of the battery, the temperature conditions of the machine where it will be put. All those factors to be reconsidered and the final outcome will be there. So how much mAh battery? So battery mAh is different in all products. So it is dependent on customer requirement. Normally it starts from 20 to 100 mAh battery. So primary battery with the long battery life, the 1% leakage every year. So you can think of a battery from 20 to 100 to 9,000 mAh. Even in some cases is going to 14,000 mAh. Mr. Prajatil is asking for the distance. He's asking for maximum possible distance of communication in kilometer. So if you are communicating in planes, you can achieve a distance of 15 kilometer, 20 kilometers easily. But here you need to keep the gateway on a height. If the bytes capacity is 50 bytes on SF12, so you need to take care of that. If you want to have a long distance, do it in SF12 with a 50 byte maximum capacity. So hope I have answered your question. Height of gateway is considered basis of the position of your devices. So you have to do a geographical survey where you need to consider the location where gateway need to be installed and the device location. So let's say you can use the Google map also, Google Earth also for doing this. You can have the location heights over there, calculate that. There should be a LOS typically for long ranges. so that there is no issue in signal propagation, because you don't know in long ranges how much trees and how much obstacle will be coming in. So better to consider that for long ranges. For shorter ranges, 3 kilometer or 4 kilometer, and you can consider gateway at the height of 15 meter or more when there is no big high rise in surrounding. So if you are installing on a 15 meter or more, it will achieve a 3 to 4 kilometer range. But consider that there is no high rise in the area. Okay. What if it's a place with lot more trees like in woods? I would understand it. What if it is? So you're talking about gateway height. I'm not sure. So if you are using it in woods also, if the gateway is in a height, you can have a communication. If the gateway is not on the correct position, you will not achieve the communication. So gateway is very, very important. The gateway antenna is important. So don't use any antenna like you purchase from anywhere. Purchase from a reliable source who can guarantee you the optimum gateway handling with the antenna. Matching is required with the gateway. So antenna and gateway has to be matched. 50 ohm impedance. How much the VSWR of the antenna is also important. And also important, the total RF survey to be done before installing a gateway. So it's LoRaWAN seems to be easy in terms of installation, but people does not achieve required distances, required performance. That happens because generally people do not use proper RF survey. It is required a proper RF survey. So it is suggested to use LoRaWAN solutions from a company who is expert in LoRaWAN. So there are many companies in India, there are many companies globally who are driving LoRaWAN. You can reach those companies and customers can have more success stories other than they do their own. So it's suggested from our side. You can reach us also. We do provide RF service solutions for LoRaWAN. We also provide solutions on network implementation for LoRaWAN. End-to-end ecosystem we can provide from starting RF survey to deploying a LoRa network server, installing gateways, getting the pilot testing done, and then handing over the complete network to. We are doing it many cities with government authorities, specifically for smart city applications. So I already said that free air you can achieve 15 to 20 kilometer easily. So no need to ask question that again and again. Yeah, it is possible to communicate between two LoRa modules. That is possible. No gateway is required. That's called as peer-to-peer communication between two LoRa modules, or point-to-point communication, or node-to-node. There are many words has been defined for that. So two LoRa modules only required. If you want to have bigger LoRaWAN module, then you have to create a star network of LoRa module, where one will be master and another will be slaves. So this master-slave communication will happen. The master has to be connected with your machine, which is maybe a computer or maybe a server that will handle data. We have a product for this, ready product, which works as a data concentrator over a LoRa module, which is a lower price than the gateway. It typically send data over 4G to your server. It can also hand over data over a Ethernet or a Wi-Fi to your server. So this product is already ready. It works on peer-to-peer communication between LoRa module. And if you want to do your own, you can do it. The firmware is already available online on the GitHub. It is available with some other partners also. We also provide a sample firmware for this free of cost. Okay, so but we do not suggest this technology peer-to-peer communication for more than 10 to 12 nodes. Beyond that, it creates an issue. People have used it for 50 also, but we do not support this. Please use not more than 10 nodes, because it doesn't support the specification of LoRaWAN. It works in a physical layer of LoRa. which doesn't have the complete ecosystem of all spreading factor, all frequency hopping technologies. So you asked about the name of the module. It is Minimode 20. We use it for it predominantly. However, we are developing for other modules also. Please discuss the use case of wildlife monitoring. What the typical battery life expected. So if you want to use it for tracking, you know, uh, wildlife tracking is possible. Definitely, you can track the movement. The gateways can be installed in few locations of the jungle area, and you can have a battery life like typical 1 to 2 year battery life can be expected, because battery will not be bigger when it has to be attached with someone as a livestock. Yeah, government, we have seen from Sendra. Sendra is a network service provider for LoRaWAN. They have given this example of animal tracking, a tiger tracking project they have done. So government is using this. So I think one more questions are coming. So any more question? You can reach us on our Facebook or LinkedIn or Instagram handles. You can reach our on emails or phones. Any more questions, you can reach us. For product inquiries, also you can reach to us. We also support co-development of the products where you want to have your project and you want to get it developed with us on a LoRaWAN ecosystem. We support that also. Please reach us for those kind of requirement also. And we are committed for growth of LoRaWAN, and we also collaborate with the ecosystem partners who are already available in LoRaWAN, maybe a network service provider, maybe someone from module side itself. LoRaWAN server is it is a bigger architecture. So it won't be able to discuss in few minutes, but we can tell you that there are typical architecture of LoRaWAN. Then you have a LoRaWAN network server, LoRaWAN application server, and you also have gateway bridge. So gateway bridge typically takes data from gateway. A standard architecture is there in terms of frame. So if the frame is fixed, the frame has been taken by the gateway bridge, it is handed over to LoRa network server. LoRa network server typically handles the bands, the frequency band, like you're working in which band, ISM band, or maybe European band, or maybe in some Indonesian band. So those can be handled by LoRa network service called as LNS. And then we have LoRa application server, which creates application. Like one customer can have multiple applications. So you have an application of animal tracking. So one animal tracking application will be created. There can be integration can be created with that application. Like you want to send this data to some one designated location, server MQTT or maybe STTP or maybe some other integration. So single application can be connected with a single integration. So you can have a multiple application with multiple separate integrations. So in a LoRa application, so you can have many customers, many projects running in the same server. Also, you can create backend APIs, different APIs per application. You can also handle your device classes in that, like someone activation happening on device class A in some application, another is in device class C, or even in the one application we can have multiple things. So LoRa networks is a bigger architecture. It needs a detailed discussion, detailed training is required to implement that. We propose and we suggest all of customers not to go in detail with LoRa network server. It creates issues in terms of the implementation. We have seen many customers coming to us asking for modules and gateways. They purchase gateway and modules from us, and they want to implement their own network server. But finally, it delays the project. It goes into 2, 3, 4 months delay. and finally they come back to us for implementation with us. So we suggest that if you have a real expertise on LoRaWAN, please go to LoRa Network Server. Otherwise, please work with some LoRa Network Service provider or someone who can implement LoRa Network Server for you. So there are many applications and companies available who can help you on implementation of LoRa Network Server, including we. We do not charge very high amount for LoRa Network Server as well. So I think we have concluded on the time today. It's already 4 minutes over that. For remaining more question, you can reach us on our communication channels, which discuss in social as well as email. So that's we conclude for today. Tomorrow we will discuss on the live cases. We will show you how the devices are working. We will show how network server is behaving, how the data is going through gateways and devices, communicating or our portal, and how our devices behave, what is the time. So all this we will discuss tomorrow. So see you all